Hello everyone, in this video we are going to learn about the application of derivatives in finding out the square root of a given number. Let's suppose you want to find out square root of this number, or if you want to find out cube root of any number, or if you want to find out fifth root of any number, then we can calculate by using derivatives over here. Let's see how we can solve these types of question, which is known as approximation method, with the help of derivatives. Let's see this question, children. You have done the calculations, or you have calculated the square root of this kind of number in your previous classes by your square root method. Here we will be finding out the approximate value of this with the help of derivative. Now children, whenever you are given with this, you always consider this as y and this complete term as x. So I can write it as y equal to, this is say your x, this is the complete value, root x. So let y equal to root x. Now children, if you are given with this kind of number, then this is, which is your perfect square, because here I am calculating square root. So I'll try to get a perfect square number here. It is already given in the question, perfect square number, so I'll not be changing it. So this is your x, and this after decimal, which is the number which is written after decimal, is taken as del x. Okay. Now here, whenever you are doing these kind of question, you need to know this thing, that we write dy by dx as change in y with respect to x. This can also be written as, in approximation, as del y by del x. What is this del? Del is a small change in the value of y with respect to small change in the value of x. So I am doing here dy by dx can also be written as del y by del x. So this is again a small change in the value of y with respect to x. This is also a small change in the value of y with respect to x. So I can find out del y here by writing it as dy by dx into del x. This is the thing which we are going to use in solving this question. So here I can write this y equal to root x as, since I need dy by dx over here, so I will be calculating it as dy by dx equal to 1 by 2 root x. Now children, I told you that your x is 25, that means this will be 1 by 2 root 25, which will be 1 by 2 into 5, which gives me 1 by 10. This is the one thing. One step you need to calculate dy by dx. Another thing, you have to write del y equal to dy by dx into del x. Now, if I want to calculate small change in the value of y, then I will be calculating my small change in y here by writing it as, if I want to calculate small change in y, then I will be writing it as, this is your small change in the value of x minus your root x. That means this is the increased value and this is your original value. So if you subtract your original value from your increased value, then you will get a small change in y. So here you know this x plus del x is 25 by 25.3 minus this x is your 25. This is your del y. So I can write del y equal to under root 25.3 minus 5, or I can write it as under root 25.3 will be equal to del y plus 5. That means if I want to calculate value of this, I should be knowing del y, and this del y I will be calculating from here. So let's say this dy by dx I have already calculated, and it is coming out to be 1 by 10. So this is 1 by 10. That means I am calculating the value of del y. So this is 1 by 10 into, what is your del x? Your del x is 0.3. So I will be writing it as 0.3. So I have got my del y as say this is 3 by 100, or I can say 0.03. So this del y value I can place here to get the value of root. So 25.3 will be equal to, del y is what? 0.03, and this is plus 5. So the approximate value of under root 25.3 will be equal to 5.03. So this is your approximate value. Have a look. Now let's see this question, children. This is given 0.009 raised to power 1 by 3. So I need to find out cube root. I will be changing the given question into a perfect cube. So I can write this as 0.008 plus 0.001 raised to power, complete it is 1 by 3. So this complete is say your x and this is your del x. So simply I can write your given question as y equal to x raised to power 1 by 3. Now children, I need to calculate here derivative first of all. So dy by dx will be equal to, this is x raised to power n. So x raised to power n into x raised to power n minus 1, which gives me 1 by 3 x raised to power, this will be minus 2 by 3. So I can write this as 1 by 3 x raised to power 2 by 3. So this is the value of dy by dx over here. Now children, I told you that dy by dx is equal to del y by del x, or del y can be written as dy by dx into del x. So here I know the value of dy by dx and it is 1 by 3 x raised to power 2 by 3 into del x, and your del x is 0.001. So I can replace it with 0.001. So say this is 0.001. So this is your del y. Now here small change in y will be equal to your small change in, I can say it as x plus del x. Since it is 1 by 3, so I am writing this minus x raised to power 1 by 3. So your x plus del x is 0.009 raised to power 1 by 3 minus your x is 0.008 raised to power 1 by 3. So I can write this as 0.009 raised to power 1 by 3 minus, this will be just your cube root, you are calculating cube root. So it will be your 0.0, it will be your 0.2. Now this is your value of del y, and if you want to find out the value of this, then this will be 0.009 raised to power 1 by 3 will be equal to del y plus 0.2. Now I know the value of del y from here, so I can substitute it here. This can be 1 by 3 x raised to power 2 by 3 into 0.001 plus 0.2. So this is the value of, this is the value of your 0.009 raised to power 1 by 3. I have just substituted the value of del y from here. Now you need to solve this. So I will be getting it as 1 by 3, and what is your x over here? Your x is 0.008 raised to power 2 by 3 into 0.001 plus 0.2. So I can get it as again 3 into, this is 0.008 and its cube root, I can write it as 0.2 raised to power 2 into 2 by 3 cube. This is 0.2 cube, so this and this gone into 0.001 plus 0.2. So I will be getting it as 0.2 raised to power square. So I can write it as 1 upon 3 into, this is 0.2 whole square, which will be 0.04, and here it is into 0.001 plus 0.2. So I will be solving this and then I will be adding 0.2 to it. So let's see what is the answer coming out. So on solving, I am getting it as 0.208. Approximate value of 0.009. Cube root of this will be equal to this. Now children, see in this question, when your function is not given a numeric value and when it is given in terms of x, that means if it is a function, then what you have to do in these types of question. Here it is given, find the approximate value of f2.01. That means this is your x and this is your del x. But children, your function is defined as this, so you will be writing it as fx plus del x equals, you will be writing it as fx plus your change in del x, that means your change in fx. Now this del fx means here fx plus this change in fx means del y. Remember in the previous question we had written del y equal to dy by dx into del x. That means this is the change in y. This is the change in y. So this is your y here. That means I can write it as dy by dx into del x. So here what you need to do, you need to find out dy by dx from the given function, and then you will be putting all those values which is required here. So here fx, x means 2, that means you will be writing it as f2 plus you will be calculating differentiation of this into your del x is 0.01, or I can say 0.01. So first of all, let's calculate your f2. So say this is my equation 1. So calculate your f2. When you will be putting x equal to 2, then it becomes 2 whole square plus 5 into 2 plus 2, which gives you 16 plus 10 plus 2, or it will be, this is 28. So here in equation 1 you will be writing it as 28 plus, now you require dy by dx. So here your dy by dx will be equal to 8x plus 5. But since you are calculating your dy by dx at x equal to 2, so you will be writing the value of x here also as 2. So this will be 16 plus 5, which is equal to 21. So substitute it here. This is 28 plus dy by dx is 21 into 0.01. So you will be writing it as 28 plus this will be 0.021. So it is your 28.021. So this is the approximate value of your given function. Children, this is just 0.21. You will be multiplying and putting points, so this will be this only. So this is your approximate value of the given function. Let's see this question. Find the approximate change in the surface area of a cube. So we are talking about surface area, so we need to write down formula for the surface area of the cube, which is your 6. It is given side is x, so I am writing it as 6 into x. So this is your, say, meter square. This is your meter square. Caused by decreasing the side by 1%. That means change in side is, since it is decreasing, that's why I am putting minus sign. Change is decreasing by 1%. 1% means minus 1 by 100 of x. That means it is changing by 0.001x, and since it is decreasing, that's why we have written it as minus. Now children, you are asked find the approximate change in the surface area. That means you need to calculate small change in your surface area, which is given by this. Since small change in the previous questions we have read, small change in y is equal to dy by dx into del x. So here small change in surface area is dy by dx. That means instead of dy by dx I have written ds by dx into del x, and del x is given by this. So simply we know s, this is 6x square. So simply we know your surface area is this. So I can find out my change in surface area with respect to its side is 12x, and here I need to just put all the values. Small change in surface area is 12x into del x is given to you as minus 0.001 into x. So it will be, this will be 12, and this is x into x will be x square. So this is the small change in the surface area when it is decreasing by 1%, and here it is meter square. unit. Again children, here it is point, 0 point. So here it is 0 point. So here it is 0.12. That's it.